everybody, and welcome to the second lesson of the third unit in grade 10 math. Last time we did some solving of systems of linear equations with graphing. Today we're going to use an algebraic technique because sometimes your linear equations will look strange and not easy to graph. So sometimes it could be easier to add and subtract equations to get rid of variables, and that's what we're going to learn today. So just a quick reminder to please hand in your assignments that you were assigned before the break. If you go to your Brightspace page and click on assignments, there is a link in there that you can submit your assignments to. If you're not sure if you handed it in or not, please let me know. Okay, solving by elimination. Well, let's start with something you've seen before. You know that we can add and subtract numbers or integers like this. You've had that information in your heads for a long time. Well, we can do the same thing with equations as long as we stack the same letters above each other. So notice here how I have two linear equations, and I can tell it's linear because there's an x term, a y term, and a constant term. If I were to give you this and this equation, you could solve it by graphing, but you would have to rearrange and make sure y is all by itself. But what we can do is instead do a little bit of math to solve for the x and y instead. So if I add these two equations, notice how 3 plus 5x gives me 8x's, but when I add my y terms, it goes away because they have opposite signs. And then I can add my constant terms to get me 24. But notice when I added these equations, the y terms were eliminated, making it easy to find x. We can figure out that x is going to be 3 because 3 times 8 is 24. And in the same sense, we can subtract two equations to get rid of a variable. So here, because I have 10 x's in the top one and 10 x's in the second one, if I subtract them, that goes to 0, leaving me with 5y equals 55. And this means I can find y relatively easily. So y is going to be 11 here because 5 times 11 is 55. So the idea here is once you have two equations and you have them stacked, you can decide to see if there's an operation, and we're only looking at addition or subtraction here, to see if we can eliminate one of the variables or one of the letters. So I don't want you to solve these equations, I just want you to look at them and decide which either adding or subtracting, would you do that you could get rid of one of the variables. So pause it here and come back to get the solution. Okay, welcome back. I will show you the solutions now. So if you take a look at these, if we subtract these two, the y's will go away. If we add these, the y's will go away. Here we can add, here we can subtract, here we can add, and here we can add again. So hopefully you were able to see that, the fact if you add or subtract these equations, you can get rid of the y terms. Now if you look at these equations, what has to be true about the number in front of the variable to get rid of these equations? Well, if you notice, these have the same coefficient. The coefficient is the number in front of the variable. So remember, if there isn't a number, it's a 1. So these have ones in front, ones in front. These are both 6's. These are both 5's, these are both 2's, and these are both 8's. So you really want to make sure you can have the same number in front of the variables in order to eliminate them. And in fact, that has to be true in order to get rid of one of the coefficients. Sorry, not coefficients, to get rid of one of the variables. So what we're going to do is we are going to solve a system here, and I'll go through this thing step by step. So our steps are step 1, we're going to stack the equations. Step 2, we're going to either add or subtract them to get rid of one of the variables. And then step 3, we're going to solve for both variables, x and y. So let's take a look at those two equations. So we're going to stack them first. So that just means putting your x's above and below each other, stack them up, and your y's stacking them, and your constants stacking them. The next thing is you're going to decide if you need to add or subtract to eliminate a variable or to get rid of a letter. So here, the number in front of my x's aren't the same, so I can't get rid of those, but I can get rid of the y's because they have the same coefficient. So, is it subtraction or adding? Well, if I added them, if I do y plus y, I'm going to get 2 y's, so that doesn't get rid of it. So that means I have to subtract them. So let's set that up. So I have my top equation minus my bottom equation. Please remember that this minus sign is going to apply to every term in the bottom equation. So 8x minus negative 3x is the same as 8x plus 3x. So that's going to give me 11 x's. Y minus y gives me 0. And 16 minus negative 5 is the same as 16 plus 5, giving me negative 11. So on the left side we have 11x, and on the right side we have negative 11. So we're going to find our x from this. So remember, to get x by itself here, you're going to, oh my goodness, what just happened? You're going to divide both sides by 11. So x is going to be negative 1. So that's our x in our solution. Remember, our solution is going to be a point, an xy point. So to find y, you're going to use one of these equations, plug in our x values, and then solve for y. So I'm going to use the top one. It doesn't matter which equation you use, you should get the same value. So I'm going to plug in for x, negative 1. So 8 times negative 1 plus y equals negative 16. So that gives me negative 8 plus y equals negative 16. Now I have to get rid of this negative 8, so I have to add 8 to both sides, giving me y equals negative 8. So my solution is my x value, negative 1, comma, my y value, negative 8. And we can actually check this in Desmos, and I'm going to show you how to do that. If you go to desmos.com, actually I'll start just from the beginning just so you can see it. So if you go to desmos.com and then you start graphing, you can type in your equation, 8x plus y equals negative 16. So 8x plus y equals negative 16. So there's our first line. To make a second equation, you can just press enter, or you can just click beneath that first equation. So the second equation was negative 3x plus y equals negative 5. So negative 3x plus y equals negative 5. There we go. And so remember, when we graph to find the solution, you just see where they intersect. And here they are, negative 1 and 8. Perfect. That's exactly what we had before. So that was our solution. So if we graph it, you can check the solution that way. So now sometimes you might need to multiply one or both of our equations before we can eliminate a variable. They might not automatically have the same coefficient in front of a variable to make it easy to get rid of. So let's take a look at an example. We have these two equations, negative 4x plus 9y equals 9, and x minus 3y equals negative 6. So our first step is to stack them. Stack them, stack them. Now notice how the x's don't have the same number in front of them and the y's don't have the same number in front of them. So we need to multiply the bottom equation so that either x has a 4 in front of it or the y has a 9. For some reason, I decided to do my 3 times 3 to get 9. You definitely can multiply by 4 as well. So I'm going to set this up so I multiply my bottom equation by 3. Now it's really, really important here that you know you have to multiply each of your terms by 3. So 3 times x gives me 3x, 3 times negative 3 equals negative 9y, and 3 times negative 6 is negative 18. So there is my new systems of equations. Okay. As long as you multiply every term in that equation, you're not actually changing the equation. Okay, now notice how we have both 9's in front of the y's, and if we add these two, we get to get rid of the y. So let's do that. Stack them up. Let's add them up. So negative 4x plus 3x gives me negative x left over. The y's cancel out, so they eliminate, and then 9 minus 18 is negative 9. And if I want to solve for my x, I'm going to divide by negative 1 on both sides. And x is 9. So now our last step here is to put in x is 9 to one of these equations to find y. And I'm going to use the second equation just because the numbers are smaller. Again, it doesn't matter which one you use. So I put my 9 in for my x, so 9 minus 3y equals negative 6, and now I get to isolate y. So first, get rid of the 9 by subtracting 9 both sides. So negative 3y equals negative 15. And now we divide by negative 3 on both sides to find y. And so my solution is my x value, 9, comma, my y value, 5. So let's check that by graphing just to see that we're right. I graphed it ahead of time, and so I put it here. So here are the two equations, and yes, our solution is where they cross is 9, comma, 5. Perfect. So that is the lesson for today. Just remember our steps are to stack, multiply, eliminate, and solve. And remember, step 2, you don't always have to do that. So what I want you to do is do at least 3 of these questions. The first 4, you do not have to multiply. The next 2, you do have to multiply. And G is a harder one. You have to rearrange and then multiply to get rid of a variable. So please choose 3 questions, but they get progressively harder, but I want you to do at least one of the first 4 and at least one of E and F. I have posted full solutions to this on Brightspace with my written out solutions if you want to check yours. So once you are feeling good with those practice problems, your exit task for today is a knowledge hook mission. So if you go on your knowledge hook site, pick the solving by elimination mission. There's 3 questions and they are for marks. This is how I'm marking you during this. Okay, so that's it for today. I hope that made sense. If you have any questions, please contact me through Brightspace and I will talk to you next time, guys. See you later. Bye-bye.